Okay, so this is the next part with our derivatives. Before you take the derivative, we need to have it in that nice general power form. So we always want our function to have that nice a to the x to the exponent plus b x to the exponent plus c x to the exponent. You get the idea, plus a dx plus an f, a g. We'll do a g over there. But yeah, we need that nice form right here, and that is not this. This is multiply. So if you see a multiplication, what you want to do is distribute it. So we're going to multiply this out. So we get 2x cubed plus 4x squared plus 6x squared plus 12x. So you always want to multiply it out. 2x cubed plus 10x squared plus 12x. Now we have it in our nice general power form, so we can take our derivative. So 3 times 2 is 6. Subtract 1. 2 times 10 is 20. Subtract 1. And then 12 is our coefficient, and there we have it. So we can get rid of that 1 if we want, but this is our derivative. So the key is to always simplify when you can. I mean, it makes sense. If you want things to be easier, you make them simpler. All right, on the next one, we need to rewrite our exponents. So this would be 5x to the 2/3, just like in the previous video. If you have a denominator, you want to make them negative. And then now we can use our rules. So this is going to be a little trickier, so I'm going to take it slow. This is 5 times 2/3 x to the 2/3 minus 1. Now there's a trick when you're doing these, so I'm going to show you it right now to make it a lot easier. But the 5 times 2/3 is just normal multiplication, so that would be 10/3 x. But let's plug this in your calculator and you should see a nice little pattern there. So 2 divided by 3 minus 1. That's what we had, 2/3 take away 1, and then we hit math, fraction, enter, and you see that it says negative 1/3. So the quick trick is this: if we're subtracting 1, all you have to do is subtract the denominator from the numerator, and that gives us our new numerator. So this is 3, backwards, subtract it from it, 2 take away 3. So if we do 2 take away 3, you get negative 1/3. So the denominator is not changing because that is the denominator of the fraction. And you can also just use your calculator and subtract 1 from it. It'll tell you what it is as well. All right, the rest is just exponents. So negative 2 times 7 would be negative 14. And then we subtract 1. So that would now be a negative 3. So negative 2 take away 1 is negative 3. And then the same thing, we get plus negative 1, x to the negative 2. So on each of these, you're just subtracting 1 all the way across. So we end up with negative 14, x to the negative 3, minus x to the negative 2. And then now we need to make sure that we rewrite all of these. So f prime of x is equal to 10 over 3 x to the 1/3 minus 14 over x to the 3 minus 1 over x squared. So the form you start with is the form you want at the end. So we really should change this to a root 3. Like that. And you can even keep continuing on to put them all as one fraction. So we could do a common denominator and rewrite it, but it's going to look worse than what it is. But we really need to remove all the negative exponents. That's the key. I do not want to see negative exponents in the answer for your derivative. I need to see them as a denominator. When we get to chapter 3, you'll see why this is mandatory. All right, the last one now. So the first one was multiply. Second one was rewrite. And then the last one is dividing. And so when we divide, if you're dividing by one term like this, this allows us to actually distribute it in a division form like this. So this is what we actually have. It's the 3x to the 5th, the 2x to the 4th, and the negative 3x are all being divided by x squared, so we can rewrite them all as fractions. And then we use our fraction rules we did before, so we're just subtracting them. So x to the 5 minus 2, 4 minus 2, 1 minus 2. So it's just numerator subtract denominator, numerator subtract denominator, numerator subtract denominator. So our f of x is equal to 3x cubed plus 2x squared minus 3x to the negative 1. And now we have our nice general power form. We take our derivative. So this would be 3 times 3, which is 9. Take away 1. 2 times 2 is 4. Take away 1. And then 3. Negative 1 times 3 is 3. And then take away 1, so negative 2. So make sure each one has dropped by 1 unit all the way across. And then again, we need to rewrite it. So f prime of x is equal to 9x squared plus 4x to the nothing, 1, and then 3 over x squared. Now we want to make sure that this ends up in the same form. So if you see that one here and here, they need to have that common denominator. So I'm going to show you 2 different ways to do that. Here is method 1. Method 1 is just plain old common denominator. So we have 9x squared plus 4x plus 3 over x squared. So each of these are going to need an x squared. So you have to multiply that top and bottom to each of them. And so this gives us 9x to the 4th. Let's put that back in green. It's like Christmas. This is 9x to the 4th over x squared plus 4x cubed over x squared plus 3 over x squared. This is 9x to the 4th plus 4x cubed plus 3 all over x squared. So that is the form that our derivative needs to be in. It needs to match where we started. Just like that. Now the second method is using factoring. So method 2. We're going to go back and use the previous one that did not have it written as a fraction. And we're just going to factor it out. So our common factor here is x to the negative 2. We always pick the smallest. So we're going to take the x to the negative 2 out. And what that means is we add 2 to each one. Just like that. So we get 9x to the 4 plus 4x squared plus 3 because we removed that x squared. And now we have 9x to the 4th plus 4x squared plus 3. And then that x to the negative 2 just goes to the bottom like that. And you notice it's the same thing. So there you have it. You can pick the method you like. I guarantee most people are going to pick this one, but I like this one. So there it is. If it's multiply, you want to multiply them out. If they're not in that perfect power form, you want to make sure you rewrite them. Everything needs to be on one line, no denominators. Then you can take the derivative. And if it's a fraction, you just divide it straight across. Well, a fraction with a single term.